for this problem number 18, what does it say? It says that prove that the function f of x equal to x cube minus 3x squared plus 3x minus 100 is increasing in R. On the entire real number line, you have to show that it is increasing. Yeah, so they don't give us the interval, but they say that everywhere it is increasing. Let's see how that happens. Generally, we were seeing like it alternates. Polynomial function, generally we have it like alternating and all that. Let's see now what happens and why that happens. Let's cross check and find out. Anyhow, for doing this, by default we know that our first step is to get the derivative. So let's get the derivative. So what's the derivative? F dash x. What happens? X cube derivative is 3x squared. X squared derivative is 2x. 3 and as it is, and derivative of x is 1. This is a number, so no derivative. So therefore this is what happens. Let's write this: 3x squared minus 6x plus 3, where there is a 3 common, x squared minus 2x plus 1. Now if you carefully observe, it's very clear to us that x squared minus 2x plus 1 is actually x minus 1 the whole squared. We could write it like that, maybe it's of some good to us. Now though they say ask us to check everywhere on the real number line, but still let's get the critical points and let's proceed like that. So we follow our procedure. Let f dash x be equal to 0. If that is the case, then 3 times x minus 1 the whole squared is 0, where you have the 3 maybe going on the other side. So x minus 1 the whole squared is 0. So because the square is 0, you'll get x minus 1 is 0, and that way x is 1. So actually you get the critical point as 1. So if you happen to break the interval, your real number line, you could have 1 to infinity and 1 minus infinity to 1. Probably you could have it like that. Then in that case, let's check how it behaves and what happens. So as usual, let's take our table. This is what do we say? Intervals. So let's take this minus infinity to 1. Let's take that interval. And from minus infinity to 1, any point we have to check as usual. So let's have the 0. 0 fortunately is there. So f dash at 0, let's check. F dash at 0, if we are checking, then it's a square. So it will be positive. So it will be anyhow 3 times minus 1 the whole square, which is going to be a positive. This is a square, so it will be positive. So it's definitely increasing here. If you go for the next interval from 1 to infinity, you take f dash at 2 or something like that. Same story, because it's a square, it's going to be positive. 2 minus 1 the whole square. No matter what be the number, just because of the square, it's going to be positive. So here also it's going to be increasing. That's how the function becomes increasing on the entire real number line. Now it's increasing on R. So therefore you can say, because it's increasing on thus, f is increasing on R. Yeah, why it happened, because we tried to divide the intervals. We looked at both the parts of the interval, but incidentally it happens to be positive. The f dash happens to be positive on both sides, so it's increasing throughout. That's it. Sorry, it does happen. That's about the 18th question. Now we go to the 19th one. Sorry. The interval in which y equal to x squared into e raised to minus x is